Hey everyone, sorry I couldn't be there today. Hopefully, I'll get back soon. We're going to switch gears a little bit today, and we're going to go to solving linear inequalities. We're going to get away from equations a little bit. We're going to deal with when things are greater than, less than or equal to, greater than or equal to. And you'll notice here from this particular problem, it says solve the compound inequality. So, compound meaning that we've got more than one here. Um, so when we have more than one, it's not that terrible. We're just going to look at one at a time when solving, and then we're going to look at how they are together. And I'll explain ors and ands, and what the difference is between greater than or equal to, and then also specifically the one difference that there is between solving an inequality and an equation. All right, there's one and only one difference, um, and that's going to show up here in this particular problem. All right, so to solve, let's start with the first example here. Um, Solving this actually is exactly the same as we would solve it as an equation. If we just pretended that this inequality was an equal sign, the first thing that we would do is we would add 3 to both sides. So we're looking at inverse operations. I need to get rid of this minus 3 first because of SADMEP, because it's being subtracted while the other 3 is being multiplied. So that's going to leave me with 3x. And this is where it's important that we're dealing with inequalities and why we should also write down the equations as well. But we have to remember to drop down that greater than sign, because there is a huge difference between greater than compared to less than. Then there's a difference between being equal to, obviously. So now the last step, since it's 3 times x, the inverse operation of multiplication is division. And once again, make sure that we have that greater than sign. So we have x is greater than 4 at this point. All right. Now the other inequality, I'm going to write it over here a little bit larger. My pen isn't really fine enough to do all the work underneath. So this is the one and only one difference that I talked about in terms of solving. Um, there's one step here. I would divide by -5 here. And that gives me my x by itself. -25 divided by -5 is +5. But anytime that we divide both sides by a negative, which we did right here, we divided both sides by -5, we have to flip that inequality sign. All right, so no longer do we just drop it down and keep it less than or equal to. We have to flip it so it's greater than or equal to. And like I said, that's the only difference between the solving process of an equation and an inequality. Anytime you multiply or divide both sides by a negative, you have to flip that inequality. Okay, so now we got to look at what do these mean together, because it is a compound inequality. And in looking at them together, I love number lines. All right, so if I have a number line, here's 0. All right, I've got 4 over here, then I've got 5 over here. And if I look at x is greater than 4, all right, the greater than means I'm not going to include 4, so I put an open circle, but I include everything bigger than 4. So that means I'm going to have everything to this part of the line. All right. Let me change colors here. And then x is greater than or equal to 5 means I have a closed circle because it's greater than or equal to. And once again, greater than means I'm shading to the right. And what you'll notice here is that the x is greater than or equal to 5 is already included in the x is greater than 4 inequality. So that's really all we have to look at. The solution of this compound inequality is x is greater than 4. Let's take a look at the next one. So reading through this question, I realized that I lied when I said that we're going to give equations and systems a break, because we got to look at a systems of equation here. So this one, Stephanie has 2 bottles of liquid, regular soda and diet soda, and in this, the amount in the regular soda bottle after X seconds when she's pouring it out is 60 minus 2.25. All right, and what I want to realize in this one is when it's 60 minus 2.25, that means she's starting with 60 ounces in that bottle, and then she's losing 2.25 ounces after every second. All right, and then the diet soda is starting with 120 ounces, and then she's losing 6 ounces every second. So, that being said, the regular soda, I'm going to put my little labels here, starts with less, but is getting poured down the drain a little bit slower. And then the diet soda starts with more, but is getting poured down the drain at a faster rate. So what I want to do here is find out when are they going to be equal. And when they're going to be equal, once we identify that point, then we can determine at what time is one going to be more or less than the other. And I forgot to throw an X in there. So looking at this, we like to put variables on one side, constants on the other side. I like to have positive coefficients for the variable. So I'm going to throw this 6x on the left-hand side to get a positive coefficient. And when I do that, I'm going to end up with a positive 3.75x. And then getting the constants on the other side, I'm going to subtract this 60 from the other side, leaving me with 60 there. And then at that point, I'm using inverse operations like we have all the time when we've been solving. So I'm going to divide by 3.75, and I get x equals 16. All right, so what does this mean? All right, so x, remember, is the number of seconds. So this means at 16 seconds, both of these bottles are going to have the same amount of liquid inside of them. So now let's look at the question. The question says, which graph represents the time when the amount remaining in the diet soda is less than the amount remaining in the regular soda? So diet is starting with more. So that means before 16 seconds, the diet soda is going to have more. At 16 seconds, they're going to be even. So that means we can't have the closed circle at 16. That's the difference between B and D when we're looking at this. So since they're equal at 16 seconds, we need to have the open circle, and then anything after 16 seconds, that diet soda is going to have less remaining in it. All right, let's take a look at the next one. So here's another compound inequality set up slightly differently from the first one. The first one said you have this inequality or this inequality. Well, this time we have 0 is less than 2x plus 6. And we also have, let me rewrite these so I have room to solve them. So here's kind of one inequality. We have 0 is less than 2x plus 6, but we also have 2x plus 6 is less than 12. So what I'm going to do here is I'm going to solve this as normal. I'm going to start by subtracting 6 from both sides, but really there's kind of 3 sides to subtract 6 from. So I've got negative 6 over here. I did not multiply or divide by negative, so I don't have to flip the sign. And I have 6 over here. And then to get x by itself, I divide by 2. So I apologize. I realized one of the problems got cut off, so I'm just going to continue it here. When I've got this inequality, there's really two different parts, but the process is the same. To get x by itself, I need to subtract 6 first. So I end up with negative 6 is less than just 2x, which is less than 6. And then I have to divide by 2 to get x by itself. So I end up with negative 3 is less than x is less than positive 3. And once again, even though I have a negative here, like even though this 6 was negative, I didn't divide by a negative 2. That's why I kept the inequality sign the same as less than. And in terms of graphing this, I look at where negative 3 is. It's a less than sign, so I'm going to put an open circle on that. And then at the positive 3, I'm going to also put an open circle on that. And x has to be in between. It's less than 3 and greater than negative 3. I apologize. I ran into some technical difficulties and didn't realize some of my work got cut off here. So skipping ahead to number 5. And this one, once again, we have two different inequalities. But what I want to point out, as opposed to the first question, is this one says and instead of or. The first one said or, basically implying like, okay, the solution can be part of one inequality, but if it's not, it's okay if it's part of the other inequality. This one means it has to be part of both solutions to the inequalities, not just one or the other. So that's how we interpret the and versus the or. Now, once again, we have to look at these separately. But kind of what I notice here is they're both 3x minus 9. So we're going to end up using the same steps here. So we're going to add 9 to this side and this side. And it's the same over here. We're going to add 9 to both sides. And I want to keep in mind that we have not multiplied or divided both sides, so we're going to keep the inequality the same. 3x is greater than or equal to 12, and 3x is greater than or equal to 6 over here. I think I said greater than or equal to for this. I meant less than or equal to. Now we have multiplication left, so we're going to divide by 3. So what we end up with is, I'm going to write it up here because I want to leave the graph part open. X is less than or equal to 4, and x is greater than or equal to 2. All right. So now we got to talk about graphing these. All right. X is less than or equal to 4. It's a less than or equal to, so I need a closed point. So I have to put that closed point at 4. And then since it's less than or equal to, I'm going to put a ray real quick here. And I'm going to shade in that direction. All right. So anything x is less than or equal to 4 is going to be to the left of 4. Now, x is greater than or equal to 2. So I'm going to put, once again, I have a closed point at 2, but now it's greater than or equal to. So that's going to be graphed in this direction. All right. And what we need to notice is that this was the overlap part right inside here. All right. This part here was only in one solution, not both. And kind of the same idea, lower than 2. That was in one, not both. But the part in between, that was both, which is why that's a solution, because of the and. So I need to get rid of both of these rays here. Let me delete that one and delete that one. And what I need to do is shade in between those 2 points. So I'm just going to use this segment tool here. I'm going to go in between the 2 and the 4. Oh, I did something wrong. Let's figure out what I did wrong here before we move on. I didn't add. I wish you guys could have yelled through YouTube and told me my mistake there. 12 plus 9 is 21. I don't know why I put down 12, maybe a little dyslexia. So x is going to be less than or equal to 7, which is going to mean that this should have gone out to here, and we would have shaded in between like that. And if I look at the explanation, that's exactly what it's going to tell us. My mistake. I'm human. Moving on. Okay. When you see something like this, when you see the inequalities kind of combined, that's an and. All right. And I'm not going to get cut off this time. I see that I'm going to end in 26 seconds. There's no way that I'm finishing this problem in that amount of time. So let me stop the video and we'll pick up with it here. Okay. Continuing on with this problem. We've got obviously another compound inequality, and as I was saying, this is kind of an and problem here. So, couple ways to do this. One way, anytime that you see a number outside of parentheses, our first thought is distribute, which we absolutely can do that. We can distribute -6 and have -6x plus 36 on the inside. Another way, though, is because it's just -6 multiplied by the parentheses and there's nothing else, we can actually start off this by dividing by -6. If you kind of think of SADMEP, the very last thing in SADMEP is parentheses. So we can actually get rid of these parentheses last, so we can get rid of that -6 there. So that's exactly what I'm going to do. I'm going to divide both sides, actually all three sides, by -6. Now keep in mind, as I mentioned before, this is the one difference in solving inequalities compared to equations, is I just divided by a negative number, which means I need to switch that inequality sign. So 90 divided by -6 is -15. And instead of the less than sign, I'm going to put the greater than sign. And then in between the inequalities, I'm left with x minus 6. And once again, instead of this less than sign, I'm going to have the greater than sign. And 102 divided by -6 is -17. And now the only thing with that x is -6. So to get rid of -6, I just simply add 6 to both sides. -15 plus 6 is -9, is greater than x is greater than -11. Now what you'll notice here is it's not in the same order. And the reason it's not in the same order is a lot of times when you write inequalities, from left to right, you want to go from least to greatest, just kind of like how they would appear on a number line. If I was putting these numbers on a number line, -11 is farther to the left than -9 is. So they like to switch things around. And notice when you switch things around, the inequalities get flipped again. All right. And that should hopefully make perfect sense, because if I just look at one of these inequalities at a time, if x is if x is greater than -11, so the alligator is eating the larger number, which in this case is x, the alligator better be eating the x when we're comparing it to -11. So that's why it also needs to be switched in that situation. So answer here is D. No mistakes this time. So what we're looking at here is Amy's planning the seating arrangement for a wedding reception. Each round table can sit 10 guests. So I'm going to go ahead and put 10R here. And then the head table can sit the bridegroom with six wedding attendants. And she expects 206 to 246 guests to attend her wedding, including the attendants. So what I have to remember is this 10R is the people that can sit at the round table, and not at the round table are those 6 attendants. So we have 10R plus 6. Now, altogether, she's expecting 206 people to 246 people. So we're going to try to solve this compound inequality to figure out, once again, how many round tables. That's what R is. So we're going to start off by subtracting 6 from both sides. How convenient that the 206 minus 6 is 200, a number perfectly divisible by 10, as is 240, perfectly divisible by 10. Incredible. So the last step, dividing by 10. So we find out that she is going to need anywhere between 20 and 24 round tables. Well, what do you have here? We've got an absolute value problem inside of an inequality study. Island's going crazy. All right. So first thing we got to recognize, in order to solve anything with an absolute value problem, we have to isolate the absolute value problem. So to do that, we have to get rid of this 4. So we have 2 times the absolute value of 3x minus 3 is less than 12. And then we need to get rid of this 2. Since it's the absolute value multiplied by 2, we're going to divide by 2. So we have the absolute value of 3x minus 3 is less than 6. All right, so now we have to remember, what does the absolute value actually mean? And the absolute value means a number's distance from 0. So this is where we get the compound inequality from. So 3x minus 3, the distance of 3x minus 3 has to be less than 6. But at the same time, all right, 3x minus 3, we got to consider the negative problem. So if it's less than 6, we also have to look at negative 6. But remember, anytime we consider negatives, we have to flip this inequality. So instead of less than, we're going to be looking at greater than negative 6. So now we got these 2 inequalities that we need to solve. Kind of doing the same thing with both of them. We're going to be adding 3. And that's going to give me 3x is greater than negative 3. Over here, it's going to give us 3x is less than 9. And then we divide by 3. And x is less than 3. Or dividing by 3 over here, we get x is greater than negative 1. So we've got D. This is the one that shows us that x is less than 3 and x is greater than 1. That absolute value one's a little tricky. Normally with the equal sign, it's just equal to 6 or equal to negative 6, but we have to realize that we have to switch that inequality sign because of that negative. All right, this next problem. Cindy has $20 to spend at the store. She buys a pack of colored pencils that cost $4 and jelly beans that cost $2 per pound. She spends more than $8. All right, so what we're looking at, she's going to spend more than $8. So what she spends, she bought $4 worth of pencils, plus she's buying jelly beans at $2 a pound there. And she cannot spend any more than $20. She could spend $20. So that's why you notice I have 2 different inequalities. Greater than 8 because it says she spent more than $8. So we can't consider spending exactly 8. But she has $20, so she could spend exactly $20. And now let's get solving. So we subtract 4 from everything to start getting that x by itself. So I got 4 is less than 2x is less than or equal to 16. Then we're going to divide by 2. And once again, I'm not multiplying or dividing anything by a negative. So these signs, these inequality symbols, can all stay the same. So she can buy anywhere between 2 and 8 pounds of jelly beans. I wonder what 8 pounds of jelly beans actually looks like. All right, so now we have to keep in mind our inequalities. The less than sign means we're going to put an open circle at 2. And I wonder why it didn't let me put an open circle at 2. The less than or equal sign means I'm going to put a closed circle. I wonder if they're not letting me put it there because they don't want one there. Oh, there we go. Now I got an open point there. And then we're going to be in between. So you can buy anything in between these 2 points. All right, let's see if I have time to get through this last one. So we got 5x minus 6 is less than or equal to negative 31 or greater than 24. Once again, this is an or, which is why we can have a split inequality here, because it could be one or the other. So adding 6 to both sides for each inequality is going to leave me with, I'll move over here a little bit, 5x is less than or equal to, negative 26. And 5x is greater than 30. That's not negative 26. I apologize. Negative 25. And then dividing by 5. I'm still not dividing by a negative. Even though there is a negative and I'm going to end up with a negative, I didn't divide by a negative. I just divided by positive 5. So that means we don't switch the inequality sign here. So we get x is less than or equal to negative 5. All right. Not this one because it's not a closed circle. So I'm looking at D down here. That one's less than or equal to negative 5 and also greater than 6, but an open circle there. So that is our answer for that. So your task right now is to go into Study Island and complete the linear inequalities assignment. If you have any questions, just go back and watch this video. Everybody has a link to this video. If you see a similar question that you have that you remember from the video, go back and give it a watch. Good luck.